My name is Jack Gore.
Richard Johnson here giving an introduction to Newton's first law. An object will remain at rest or in a straight line at a constant speed unless acted upon. Newton's first law is also known as the law of inertia, meaning an object will not start, stop, move in any direction unless acted upon.
The relevant fields for Newton's first law of motion are physics and engineering. More in-depth fields are things such as classic mechanics, deals with the motion of macroscopic objects, sports science, the motion of athletes and the equipment. Automobile engineering is needed for things such as seatbelts and the vehicle's motion. Aeronautics helps you understand how aircrafts maintain constant velocity. Isaac Newton was the one who created Newton's first law of motion. He was born on January 4th, 1643. He attended the University of Cambridge, where he got his degree in April of 1665. He became an English physicist and a mathematician. After his graduation, the plague shut down the university, and for the next 2 years he was forced to stay home. People often refer to these 2 years as his golden years. In optics, his discovery of the composition of white light integrated the phenomena of colors into the science of light, and this laid the foundation for modern physical optics. In mechanics, his 3 laws of motion, the basic principles of these modern physics, resulted in the formulation of the law of universal gravitation. In mathematics, Newton was the original discoverer of calculus. Isaac Newton worked with many other scientists during his time, including Robert Hooke, Edmund Halley, and Gottfried Leibniz. In 1687, Principia was published, which was over his 3 laws of motion. The Principia immediately raised Isaac Newton to international prominence. A fun fact about Newton is that he was born 3 months premature and was never expected to live past 24 hours. He ended up living until he was 84 years old and died of age-related causes on March 31st, 1727. The original experiment for Newton's first law of motion was an object hitting another object. These objects will either stay in motion or stay at rest. Isaac Newton faced several difficulties in his complication when formulating his first law of motion. Newton struggled to find a way to mathematically describe the constant rate of change of motion. Isaac had trouble being able to describe the continuous nature of variables like speed and direction. This led him to invent calculus.
2.3 Original scientist. Newton's first law was to understand the principles of motion and force. Newton wanted to be able to explain motion better and more accurately than other scientists. Newton's first law was no accident.
The discovery of Newton's first law of motion was based off work by other scientists. Newton's law opposed their beliefs and laid the foundation for modern physics. In today's time, for Newton's first law of motion, we would use a low friction cart on a very level track that is combined with motion sensors and a computer software. We would place the cart at rest to show it remains upright without force. Then the cart would be giving a small push to put it into motion. The cart would continue to move at constant velocity and be recorded precisely by the motion sensor and displayed as a flat line on a velocity versus time graph. Modern experiments are more accurate than back in the day experiments.
3.2 Difference in modern approach. The difference in modern day approach of Newton's first law is precision in the reduction of friction. In the 1600s, experiments set up used things like rolling balls on inclined planes where friction and measurement errors were big and hard to eliminate. In the modern approach, we use things such as air tracks, hover pucks, motion sensors, and computer software, which makes everything extremely accurate. 3.3 Modern benefits of discovery. Newton's first law of motion is used more often than not in our everyday lives. There are plenty of modern-day benefits of the discovery of Newton's first law, such as understanding why you are thrown forward when you suddenly brake really fast, or why an object you set down will remain in the same spot unless an internal force causes it to move.
It is expected that the future research of Newton's first law of motion will focus on studying motion in extreme environments, like space and near-zero friction systems. They want to push boundaries and have classical mechanics meet modern physics. The question I came up with was, before Newton created his first law of motion, what did people believe about motion? And how did the experiments by Newton make people question and change their point of view on it? Before Newton, most people believed that motion needed constant force, which was Aristotle's idea. Newton's experiments challenged this idea. Newton made people question and change their point of view because they realized motion continues naturally unless something interferes. This question is relevant to Newton's first law of motion because it explains why Newton needed to create it. Aristotle's idea was incorrect and he had everyone believing wrong.
4.2 Benefits of understanding questions. Understanding questions help you see how scientific thinking evolves. Helps you understand why motion works the way it does. It also explains why it's important to question assumptions.
The process of writing the question is useful because it's not too simple, but also not too complicated of a question. It's not too simple because it asks you to explain a major change in the scientific thinking and not to just memorize the facts. It's not too complicated because it focuses on what the people thought of him changing what they believed about motion. I decided against using what is Newton's first law of motion because it is too simple and wanted to have a question that required some critical thinking.
4.4 The uniqueness of questions. The uniqueness of questions and the fact that it connects science with the history behind Newton's first law of motion. Shows you how experiments challenge old beliefs and lead to new understanding of motion.
Newton's first law of motion does not have its own formula or constant. It is a conceptual law, so it explains the behavior of objects. The net force is F net equals 0, which would make the acceleration A equals 0. The object stays at rest or moves at a constant velocity. Newton's first law of motion would not have a solving process since it has no specific formula or constant. It is a principle or a statement on how at-rest or moving objects behave.
5.4 Solution. Any solution that shows zero net force and zero acceleration is applicable to Newton's first law of motion. If the external force acts on the object, it will remain at rest or move with a constant velocity. There is no formula or constant for Newton's first law of motion because it is a principle on the object's behavior. 6.1 Additional valuable information. Newton's first law was almost Galileo's law. Galileo laid the foundation for this law before Newton refined and formalized it. You experience Newton's first law every day when you're on a bus and you feel a jolt and your body keeps moving. That's Newton's first law. So basically, if the bus stops and you, that's a jolt.
A student would be interested in Newton's first law of motion because it applies to everyday life. It shows how friction and forces affect motion, which is key in sports, driving, and engineering. It sets the foundation for understanding all other motions in physics.
6.3 Overall summary. An object in motion stays in motion unless acted on by an external force. Isaac Newton formulated his law of motion in the late 1660s, but they weren't published until 1687. He developed his idea during the scientific revolution, a time of major advancements in science. The tendencies of an object to resist changes in its state of motion is called inertia. Force equals 0. If the net external force is 0, then the acceleration is also 0. Newton's first law of motion.